So, water. And yes, we are going to talk about this water today, but we can't get started not until we see what we need for all of our experiments today. We are going to be needing the bag that has a piece of paper in it, a little tiny cup, a little mini pipette, some salt crystals as well, among a whole bunch of other stuff. That is the bag that we do need for today's experiment. And then these are things that are not included, so go ahead and go throughout your house, try to grab some of these. Some sort of towel, small towel, some sort of plate. I have a little styrofoam plate here, and a bowl of water. Okay, if you have a larger cup, that would be good too, but a bowl would be better. So we need some sort of bowl of water. Anyway, besides that, that is all that we need for today's experiments. And like how I said, we're gonna be talking about water. So now, when you think about our planet Earth, guys, do you know what it's mostly covered in? Is it mostly covered in chocolate? No, it's not covered in chocolate. I wish it was. It would be very delicious also. But no, it's mostly the surface of our planet Earth is covered with water.
That's amazing!
Yeah, pretty cool, right? And we absolutely need this water. It helps us to be able to live, but not just us. Plants, animals, trees, flowers, right? All of these living organisms, they all need water. And we can do so many things with it. Of course, right, we can drink it. We use it to, you know, clean stuff. We use it to, take a bath. Take a shower. Oh. But maybe not right now, right? Or go swimming, right? Dive into it. Sometimes you could even go surfing. Oh. Oh, yeah. You could go surfing with that water, right? So it's not just used to help us to survive and to live, but all sorts of other stuff. And when you take a close look at this water, it's actually pretty sticky, believe it or not. Yeah, it has two properties that we're gonna go over today, which is called cohesion and adhesion. Basically what this is that whenever water is touching something else, it actually sticks to other things. We call that adhesion. And then also, guess what? Water loves to stick to itself, which we call cohesion. And you know what? We're gonna do a small little experiment to show us how cohesion and adhesion works. Here we go. Okay, so now we're gonna go paper fishing. But how are we gonna do that? Well, before I tell you, grab these parts. There should be stacks of paper. There should be 4 pieces of paper stacked together. Grab that, grab your large bowl of water and your towel for the messes. Okay, now of these 4 pieces of paper, we actually don't need all 4. Just leave 2, put the other 2 to the side, okay? And what we're gonna do is we're gonna go fishing. We're gonna try to catch, not fish, but paper. So how are we gonna do that? Well, first we need small little fishies, papers. So just take one of these and we're gonna rip it right in half. So what I like to do is I like to put both of my fingers on the very top, rip a little bit, and then pull it straight down. Does not have to be a perfect cut, but we've ripped it in half. Then take each of these and rip them again in half. Just again, put your fingers on the top, rip it a little bit, and then pull it down, rips it like that. Then same thing with this one, right? Rip it a little bit right on the top and pull it down, donezo. So what I've done is basically I've ripped one of the pieces of paper into 4 pieces, and now I'm gonna try to catch it with my fishing pole. So here I go, ready? Get set, and... Ready? Oh, I didn't pick anything up, but maybe we could use something a little bit sticky. Do you remember what else is sticky? The water, yep. So we're gonna dip this piece of paper into the water, making it sticky. Remember, water likes to not only stick to itself, cohesion, it also likes to stick to other things, which is called adhesion. So let's see if that property is gonna help us to catch some fish. So just go ahead and take your paper, dip it in there, get it nice and wet. Once you're ready, then just put it right on top. Maybe tap it a little bit. Let's see how many fish I was able to catch. Here we go, ready, get set, and I got all of them. Take a look at that. So what's really going on? Well, of course, earlier it didn't pick it up, but now it's picking it up because we put some water in there. And we already talked about how they are sticking together. So how does water make it stick? How does cohesion and adhesion really work? Well, first thing I want to tell you is just as everything else is made out of these tiny little things called molecules, same thing with this water. Okay, so water is made out of little tiny molecules, and what's special about water is there actually has two sides. There is a positive charged side and then a negatively charged side, and what happens is that they're actually very attracted to each other, kind of like a magnet, stick to each other. So as you can see, it's sticking to each other because one side of the paper is wet, has the water molecules, and the little fishies also have the water molecules. And guess what those water molecules like to do, right? They have a positive charge and a negative charge. They attract together, which causes it to stick together, which is what we call adhesion. So that's what's really going on. Have you ever seen a bug skating across the water or in a pond somewhere? Yeah, they're usually like just going nice and easy right on top. You ever wondered how they're able to do that? Well, it's a really cool phenomenon called surface tension.
What is surface tension?
Well, if you remember, water likes to do those two things, right? It likes to stick to itself and it likes to stick to other things, right? Sticking to itself is cohesion, to other things is adhesion. And what's interesting is the way that it sticks to itself all over inside of the pond or the water, the body of water. And while it's sticking to itself, it sticks even stronger, the strongest, right at the surface of the water, to the point where even small little objects and even animals and insects are able to float right on there because it's sticking even stronger to each other through that surface tension. So we're gonna do a little experiment to kind of experiment with this surface tension, not scooter tension. All right, so now let's check out about this surface tension. Remember, surface tension is just how much stronger it is right at the very surface of the water, to the point where things are able to float on top of the water. So we're gonna try to do this with these parts that we have here. So grab yourself still that bowl of water and all of the buttons that you found inside of the bag, and let's still keep this towel around to make sure that things are nice and dry in case we do spill, and also to keep our fingers nice and dry. Okay, so like how I said, the surface of this water is a lot stronger than everywhere else inside of this water, which is called that surface tension, to the point where you can take your little tiny button, and if you go nice and easy, nice and slow, you'll be able to make it float. Okay, so again, there's actually a trick to this. Okay, you can't just take your button and drop it. It's not gonna work. Also, if it's already inside, if it's already wet, it's not gonna work. Okay, your fingers and the button needs to be dry in order for this to work. And also, the way you put it in has to be very specific. When you put it in, you have to hold it with your two fingers on the outside like this. It has to be nice and flat. Your button can't go straight down like that. That's not gonna work, okay? So the way I like to do it is I just leave the button on the table or wherever you have it and take two fingers. I like to take my pointer finger and my thumb and grab it on the outside, just like this. Remember, we don't want it to go sideways, right? But you want it to be as flat as possible, and you want to start putting it down nice and slowly, nice and slowly. Don't drop it from really high, but you want to drop it as soon as your fingers start to get just a little bit wet, okay? And then she'll just come in nice and easy, and you can let go and ta-da! And this doesn't just only work with small buttons. Here, let me try this bigger button here. See how big that is? That's really big. But if you follow everything that I said, right? Hold it on the outside like that. Don't drop it from super high, but come in nice and slowly. Once your fingers start getting a little bit wet, then let go slowly. And look, that's a bigger button, but it's still floating because of the strength of the surface tension that's going on here, the strength of the cohesion that is going on the surface of this water. Okay, so just go ahead and do that with all of your buttons. Again, just grab it on the outside, go nice and slowly, and then, do you remember what we do with our fingers that are wet? Dry them. Okay, dry them, and then just keep on doing the next ones. Try it again, the next one. And let me show you what happens if I try to put it sideways. See, doesn't work, right? So that's why, again, you have to keep it nice and flat, and go as slowly as you can. No need to rush, no need to rush. And if for some reason all of them fall to the bottom, don't worry about it. What you could do is just take out the ones from the bottom, take them out, make sure they're nice and dry, and try them again. But remember, the button and your fingers need to be nice and dry in order for this to be able to float. And again, the reason why it's floating is because the water molecules right at the surface are sticking the strongest, right? They're sticking really strong right at the surface, causing it to have that surface tension and even allowing things to be able to float. So now in our next experiment, we're going to talk a little bit more about this surface tension. Have you guys ever noticed whenever it rains, especially on smooth surfaces like on top of a car, you'll notice little droplets of water, but it's not like a whole puddle. They're kind of like in little tiny beads, right? They form little beads of this water. And the reason why is because of surface tension again. So what's really happening is, remember, there's the cohesion that's going on with the little water molecules. They're sticking nice and close together to the point that it kind of acts like a bag, keeping all of that water in without letting it leak out. That's why it's a little tiny bead of water, right? So let's see how this works in our next experiment. So for this experiment, these are the things that we'll be needing. We'll be needing that towel again, and the flat plate, and also the penny that came from inside of our bag, our large bowl of water, and our little mini pipette. So what we want to accomplish through this experiment is to see how that surface tension kind of acts like a bag that holds the water in and it doesn't let it leak, okay? And so to do that, we're gonna start putting little droplets of water onto our penny, and you're really gonna see how it forms this kind of bag around it. But first, we need to do something with how we use this little mini pipette and how we put water onto there. So there are two things we wanna learn, which is how to use a pipette and how to put small little tiny drops of water onto our penny. So first, if you remember, the way that we use the pipette is we just gotta put that mini pipette right inside of the water and then squeeze it. And after you squeeze it, you gotta let it go, right? You gotta let it go while it's in the water, and you should see some water inside of that mini pipette. And the second thing we need to learn how to do is only drop one droplet of water at a time. So when you squeeze it, you don't wanna squeeze really hard where everything comes out. We don't want that to happen. But instead, we only want little droplets of water, at least one drop at a time, kind of like this. So if you squeeze it gentle, very, very gently, it'll be one drop at a time. So try that first, and once you're able to do that, we want to put one drop at a time onto our penny and try to count to see how many drops it takes until it spills all over our penny. But you'll notice that the more water droplets that I put onto here, it's just going to get bigger and bigger, and it's going to get taller, but it's not going to spill yet because the surface tension is going to hold it from all sides, not letting it leak. Okay, so here we go. Remember, one drop at a time and count your drops. So here we go. Ready? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm not going really high, I'm going kind of close to it, right? 12, 13, 14, 15, 16, 17, 18, 19, 20. We get some more water. 21, 22, 23, ooh, 24, 25, 26, 27, 28, 29, 30. I'm at 30, it hasn't leaked yet, but you could see it's starting to bubble upward. It's not leaking yet, but it's forming like a bubble here, and the surface tension is really keeping it nice and tight so it doesn't leak. 30, right? And 31, 32, whoa, 33, oh my goodness, 34, 35, wow, that's going really tall now. It's still not spilling. 35, 36, 37, 38, Oh, yeah, it's getting really wide. 39, 40, oh, 41. Yeah, it's still not leaking because it's holding on nice and tight because of the cohesion right on the surface, which is what we call surface tension. 42, 43, 44. Oh, and there it goes. It finally spilled. Now what you could do is you could do it again, but you can't do it while it's wet, like our button float experiment. You got to make sure you dry your coin and also dry your plate. You just, pour that out and then dry your plate just a little bit. Do it again. Make sure your penny is nice and dry. Then do it again. Remember, we're not squeezing all the water. We're just doing little droplets at a time. But again, you could try it again and again. Try to see if you could get a higher number. I was able to get 43. What did you get? But in any case, the whole point of this experiment is to show us how that surface tension is acting like a bag, holding all of that water in without letting it leak. And you can really see how it bubbles up, right? Which is pretty cool. So I hope you guys had a lot of fun with this experiment. Do you guys know why we only see rainbows when there are rain clouds up in the sky? Well, it's because of another really amazing property that water has, which is called refraction of light.
Refraction, what is that?
Well, it's basically just the big science word for bending. Whenever it's bending that light, that's called the refraction, okay? And what's really happening is once it starts raining, the little droplets of water, when the light goes through that little droplet of water, it basically bends that light, which we call refraction. Okay, so once it refracts or once it bends that light, what happens is you're able to see the rainbow. But not only can you see the rainbow when refraction happens, it also makes smaller things look a lot bigger. We call that magnifying. Okay, so we're going to take some small things and we're going to use that property of water, which is called refraction, bending of that light. We're going to make it magnify little objects in our next experiment. We're basically going to be making a water magnifier. So to build our water magnifier, these are the things that we need. Rubber band, that full top bag that came from inside of the bag of everything, the cup, and the rock salt. And I picked a few of my smallest pieces of buttons here. And aside from that, you could also maybe take like small little things you might have at home, maybe some sand if you guys have some rocks, small leaves, small toys. We just want small things to look bigger with the water on top. Anyway, also, we would be needing our large bowl of water and the little mini pipette. So first things first, we need to put our tiny things inside of there, like the rock salt. So go ahead and open that bag and just pour all of them out. Okay, there you go. And after you do that, take some other things that might be tiny from home. Now, since I don't have those right now, I'm gonna take my little tiny buttons and put them inside. Once it's in, then we wanna cover it with our bag. Now, what I like to do is I like to actually open up the bag, okay? And while it's open, kind of cover it like a hat, okay? Once you do that, then you wanna kind of fold it down so it's nice and flat. Try not to have one of the corners. See how the corner is pointy? We don't want that on top of the upper part of this circle of this cup, but we want it to be nice and flat. And what you want to do next is just go ahead and take a rubber band and just wrap that around. Okay, and technically this should be fine, okay, but I'm going to double tie it. And the way that you could double tie it is you just stretch it out, flip it over, and just wrap that all the way around your cup again, just like that. And then once you do that, then we want this to be not just only flat, but also we want to kind of push it in so that it will be able to hold some water onto our water magnifier here. So what I like to do is I just take my knuckles, so just take your fingers, just kind of bend it in like this. Just take your knuckles and kind of push down on it nice and gentle. You don't want to rip it. Especially, you do not want to rip it. If it rips, it's not going to work. If it rips, just find another part of the plastic to do this, but you want to just push very gentle and nice and slowly so it just kind of divots inward. And then what we want to do next is after it kind of indents inward like that, then we want to start putting a little bit of water and look through, and you'll be able to see that those little small objects will look a lot bigger, because what's going to happen is that the water is going to bend the light so that it makes it look a lot bigger. Remember that bending is called refraction. Okay, so just go ahead and take your mini pipette, and this time you don't need to drop little tiny droplets. You could just put the water right on top and put a little bit more. And just enough so it's not gonna spill all over. And also enough so that you can start seeing everything inside is nice and big. Okay, so just a little bit more, and I think that should be good. Okay, let me take a look. Wow. Everything is so big. Yeah, the little tiny salt crystals, the little rock salt, and even the buttons look a lot bigger, because what the water did is it bent the light, right? It made it bend, called refraction, and so it made those small things a lot bigger. Whenever small things look a lot bigger, we call that magnifying, and so that's why this is called a water magnifier. And you can see, whoa, that's pretty cool. Yeah, so again, you could try this with other little tiny things. If you really want to take a close look at the details of those little tiny things, put it inside, wrap it around again with the plastic bag, and see how they look magnified. Well, that's it, guys. I hope you guys had a lot of fun, and this has been Mega Manoa, and I'll see you at home drinking water. Oh, Just want to give a big thank you to our guest scientist for today. Thank you, you did such a great job. And if you guys want to be a guest scientist, just shoot us an email and we'll see what we can do about getting you on the show with Mega Manoa. Yeah, so just shoot us an email and then we'll see you soon.